Hello, my name's Joe Allsopp, and I've recently completed a 10-week internship with Innovation Central, where I've looked into the feasibility of using drones to conduct internal inspections on large storage facilities such as old grain silos. Many silos that are still in operation today were built as far back as the 1940s and require routine inspections and maintenance to detect structural degradation that can result in not only economic loss, but also present a serious danger. Internal inspections are typically done by a team of experts who scale down the inner walls on ropes and look for anomalies. It's a time-consuming job, and there are many risks involved, so it would make a lot of sense to replace the human inspectors with a drone. Most off-the-shelf drones use GPS positioning to work out where they are. This is what enables them to fly with such precision and minimal input from the operator. But if the signal is blocked, things can go downhill fast. I'm going to show you how I made a drone that can fly with precision without a GPS. I started with a bare platform and I installed radio gear and a flight controller so I could take it to the sky. Next, I installed an optical flow sensor. Optical flow sensors are basically eyes for the flight controller. By monitoring the ground with a low-resolution camera, the flight controller knows when the drone is moved and can therefore counteract it to stay in one place without any input from the operator. I created a collision avoidance system by mounting a LiDAR on a single-axis gimbal. The gimbal keeps the LiDAR horizontal, regardless of the pitch of the aircraft. This stops it from accidentally picking up the ground when pitching forward. LiDAR stands for light detection and ranging, and calculates the distance to an object by emitting pulses of light and recording the amount of time taken to detect a reflection. I made two different flight modes using the LiDAR. Flight mode 1 prevents the drone from flying any further forward when it's too close to an object. Flight mode 2 lets the operator choose how close the drone is to an object using a slider on the transmitter. With optical flow positioning and a collision avoidance system, this drone is capable of flying in GPS-denied environments with great precision and little input from the operator. With some future development, including the installation of an inspection camera and certification to Australian safety standards, it could be used to conduct internal inspections in confined spaces and not only save time and money, but also prevent the risk of personal injury or even death. This project has been a great learning experience and has given me the opportunity to take what I've learned at university and combine it with my passion for aviation. It's given me an insight into practical engineering outside the lecture theatre and introduced me to the fascinating yet demanding world of time-constrained contemporary engineering research. I would like to thank Innovation Central for making this project possible, and my industry sponsor, C4D Intel, for supporting me along the way and providing me with a bare platform to build upon.